I'm going to help walk you through this derivation of the Work-Kinetic energy theorem. It's probably the most important theorem in mechanics. So we're starting with the definition of work, general definition of work. We're assuming that that the summation of forces, the resultant force, this is if you want to find the overall work done in the system. So although you normally find work done by one force at a time, but anyway, so I kept that summation of force to keep it general. And the delta x, in this case delta s, are parallel to each other, okay? So you're supposed to, I gave you step one, I gave you the final step, and you're supposed to come up with the little puzzle here is to come up with the steps in between. So we see a couple of things you notice, that there's mass and there's velocity in the work-kinetic energy theorem, and there's none in what you're starting off with. So we're going to do some substitutions, it looks like. So you try it and then pause it and then see what I say. Okay, so I'm going to show you step two in it. Pause it and I'll show you step two. All right, so there's step two. I told you we needed to bring in some mass to get that into the equation. Along came acceleration, so it looks like we're going to have to do some kind of a substitution for it as well. So think about it and go to the next step. You try it first, and then I'm about to put what I put. Okay. All right, so step three, I substitute it back in. So first you have to introduce it into your derivation, then you have to substitute it in. Okay, remember it goes intro, iso, sub. It was already isolated, so I just substituted in for acceleration. I'm going to put force. I'm going to put the acceleration and delta x together here for a reason. Maybe you start to think orange. So now think what the next step would be. All right, so step four was to bring in the third orange equation. And you can see where I'm going with this. We're going to need to do a sub next. Probably actually this is an intro, then we'll probably do an iso, then we'll do a sub. Okay, so the next step was, as we talked about, is isolating or rearranging the third orange equation, and then obviously the next step will be the sub. There you go, there's the sub, and now the only step left is to distribute the mass across to both and factor out the 1/2 so that it goes into both. And there it is, there's the work-kinetic energy theorem. The pocket version is simply this. The pocket version looks like this. It says summation, oh boy, these are the wrong pens. Summation of work equals delta K. That's what you get the tattoo of. Summation of work equals delta K. All right, that's it. Thanks.